कहाँ तक किया था हम लोगों ने? Okay, just to recap a bit, guys. So we lastly dealt with chiral molecule and enantiomers. So we said that enantiomers are non-superimposable mirror images, and enantiomers they rotate the plane polarized light in opposite direction with the same magnitude. If one is rotating 60 degree in the right clockwise direction, the other is going to rotate in the anti-clockwise direction. Okay. Now, on the basis of this, there are a few questions that can be asked. So let us see those questions. And these are the only questions which will be formed. I mean, they cannot form any other typical type of questions. Okay. So please write the question. When plane polarized light is passed through racemic mixture, then what could happen? The option number one is plane polarized light will rotate in clockwise direction. Second is PPL will rotate in anti-clockwise direction. Third is plane polarized light will not rotate. And the fourth one is none of the above. Okay. Now, how many of you guys remember what is racemic mixture? Oh, anyone remembers racemic mixture? Nobody
Yes.
remembers race. What is racemic mixture, Sufyan? Tell me.
Half half is dextro, half is levo.
Correct. Half is distro and half is. I think the last topic that I think we only did was that, no? We were studying SN1, SN2, है ना? तो इसमें क्या होता है? न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन SN1, हाँ ठीक है, यहाँ पे मैकेनिज्म होगा, ठीक है. So in this, what we get in this we get 50% inversion product and 50% retention product. As you can see, both of these compounds are mirror images of each other, है ना? Can you see that, guys? Like if I place these two, then first the retention product is the mirror image of the inversion product. So these are also what? These are enantiomers, है ना? And the mixture that contains 50% inversion and 50% retention product is called racemic mixture. So racemic mixture में क्या होगा? There will be both the enantiomers will be present. Now what will happen? The first enantiomer, let's suppose the A enantiomer or the inverted product, okay, the inversion product, what it will do? It will rotate 60 degree in the clockwise direction. So I will say plus 60 degree. The retention product, it will rotate minus 60 degree. So overall rotation will be cancelled and the net rotation will be equal to zero. So when it is in racemic mixture, what happens? The plane polarized light will not rotate. And what is the reason of not rotating? Because the rotation from one of the enantiomer is cancelled by the other enantiomer, because both of them they rotate the plane polarized light with the same magnitude. ये भी 60 degree, वो भी 60 degree, but एक anti clockwise और एक clockwise में. So what will happen eventually? The net will be zero. Make sense? Yes or no? Please tell me.
Yes.
What about others? Mariam and Amna.
Yes, sir.
Okay. अब इसी से सिमिलर ही सवाल है, जैसे ना फॉर एग्जांपल दे विल आस्क लाइक दिस, प्लस माइनस, दैट इज प्लस माइनस 2 butanol is optically inactive. Why? So in this case, the reason is, what does the plus minus say? Plus minus says that both the dextrorotatory and the levorotatory butanol, 2-butanol form is available. Now in this, what is going to happen? You can write it is optically inactive because plus 2-butanol cancels the rotation caused by minus 2 butanol and vice versa. Simple. Another thing that they can ask is reactive mixture is optically inactive. Why? The answer will be because it contains equimolar mixture of two enantiomers. Therefore, rotation caused by one enantiomer is cancelled by the other. Therefore, reactive mixture is optically inactive, है ना? एक और पॉइंट ना जो एनसीईआरटी में लिखा हुआ है, चलिए इसको लिखिए फिर हम एक चीज, देयर इज वन वर्ड दैट आई हैव टू एक्सप्लेन. Write this down, raise your hand once you are done. Waiting for Mariam and Sufyan. ठीक, देख एक चीज समझिए जरा, ठीक है? नो नीड टू राइट दिस डाउन, प्लीज ट्राई टू अंडरस्टैंड. So let us suppose this is carbon atom. This is here OH, here also OH, here Br, here also Br, here is chlorine and here is chlorine. ठीक है? तो I know this, you may not know it. ठीक है ना? बस हम बता रहे हैं यहाँ पे. Both of these carbon atoms, this carbon I would say, this carbon atom and this carbon atom, they are chiral carbon. And I hope you can see that both of them, they have 4 different groups on it, right? Now I know this from, as a fact I am saying. Also you can see that these are mirror images. अगर हम इसको तोड़ दें, then you will see that these are mirror images. So you can see that this particular thing and this particular thing, they are kind of not enantiomer. वो enantiomer बोला नहीं जाता है, बस ये है ना कि if this carbon atom, it will rotate the light into in plus 30 degree, then this carbon atom is going to rotate the light in minus 30 degree. Now you can see that here also, if I take, even though this particular carbon atom, it is what it is having chiral it is having a chiral center, chiral carbon, but the molecule is not chiral, because if I take the solution of this particular molecule and I pass a plane polarized light, then the light will be rotated plus 30 degree and minus 30 degree, the net will be 0. Now in this case, the first carbon atom is compensating for the rotation caused by second carbon atom, है ना? First carbon atom is compensating for the rotation caused by second carbon atom. So this type of compensation is known as internal compensation. Internal compensation. That means the compensation is coming within the molecule. एक ही molecule के अंदर उसका तोड़ मौजूद है, right? The disease and the medicine is present in the same molecule, not the disease and the medicine, but I'm saying like minus 30 degree assume disease, plus 30 degree is the medicine. Okay, so both of these things are present in the same molecule, so it is, that's why it is known as internal compensation. But when we come to enantiomers, so for example, let us suppose this type of enantiomer is there, one carbon, second group, third group, and fourth, and the enantiomer will be like this, mirror image. You will have 1, 2, 3, and 4. Now, in this, what is happening? This particular carbon atom, it is rotating, let's suppose, plus 45 degree. So this carbon will be rotating minus 45 degree, right? Now, in this case, if I take a mixture of both of these compounds, then the plane polarized light will not rotate. In this case, the compensation is happening externally. The compensation of this rotation is present outside the molecule. Okay, so in racemic mixture, what happens? External compensation happens. So you can write a point. What is this? Racemic mixture is optically inactive due to external compensation. Due to external compensation. All of you understood this particular point? Yes or no? Please tell me. जी बताएं, आमना, सुफियान, मरीम, आपकी आवाज नहीं आ रही है. Yes, Sufyan, you understood this? External compensation? किसी की आवाज नहीं आ रही भाई, क्या हो गया? हेलो, हेलो, am I audible guys?
Yes.
Yes,
अच्छा
sir.
आप, ओके ठीक है, बोलिए ना भाई, आए समझ में तो बोलिए. डू यू वांट टू राइट एनीथिंग अबाउट, या हो गया सब कुछ? हो गया ना? आई थिंक या ठीक है, बस इस लाइन को लिखिए, देन वी विल मूव ऑन. So that's the end of haloalkane and halogen. We are going to start for alcohols, phenol, and ethers.
Assalamualaikum, sir.
वालेकुम सलाम.
कैसे हैं?
आप यहाँ, अल्हम्दुलिल्लाह, I'm fine. How are you?
I'm fine and
Is this your first class? नहीं ना, आप पहले आए थे ना, लास्ट वीक आए थे, आप नहीं आए थे?
आई थी
आए थे ना?
जी.
Okay. ठीक है, so we are starting a new chapter, that is alcohol, phenols and ethers, and this will be a bit smaller than haloalkane halorine, even though we are going to cover a lot of more reactions in this case. But since we have done a lot of work in haloalkane halorine, we will be able to do it pretty much more quickly than the previous chapter. Chapter's name is alcohols, phenols, and ethers. Alcohol, phenols, and ethers. आराम से रीडिंग कीजिए, फिर हम लोग स्टार्ट करते हैं, धीरे धीरे स्टार्ट करेंगे. चलिए, पहले ये बताइए, आर यू कंफर्टेबल विद द नॉमेनक्लेचर? यस और नो? प्लीज टेल मी.
Yes.
या ठीक है, चलिए, तो नॉमेनक्लेचर हम पहले एक दो एज एन एग्जांपल, मतलब सवाल ही करा देते हैं सीधे सीधे, ठीक है ना? आई एम नॉट टेकिंग द थ्योरी ऑफ नॉमेनक्लेचर. चलिए हम सीधा स्ट्रक्चर ही बनाते हैं, क्या सोचना चाहिए. CH3, कार्बन, CH3, OH, CH2, CH3. What would be the IUPAC name of this molecule?
Two methyl propan butanol.
हाँ ठीक है, देखिए, how to do the nomenclature? If you guys remember, first of all we'll identify the functional group, that is OL, all alcohol. Then after that, unsaturation, is there any double bond or triple bond? No, there is no double bond or triple bond. That is why we'll be writing AN. Then after that, we are going to identify the parent carbon chain. So the parent carbon chain should contain the functional group. So this carbon atom should be there. For this carbon atom, I can do this. This is my parent carbon chain. It is having 1, 2, 3, 4 carbon atoms. So this will be bute. And now substituent. So anything that is remaining after the identification of parent, unsaturation, and functional group, right? Okay, so whatever is remaining after the identification of this part, it is known as substituent. So CH3 is what substituent, which is methyl. Now, once you are done with this, then you have to number it. Numbering should start from that terminal carbon atom to the last carbon atom, which is nearest to the functional group. So either we can do this type of numbering 1, 2, 3, 4, or we can do from this side, that is going to be 1, 2, 3, 4. Now, in which case the functional group is getting smaller number is the second case, sorry, is the blue case. So I will take that blue case and we can say that functional group is in the second position, the methyl is also in the second position. That's it. We don't have any unsaturation. That is why we are not going to number the unsaturation. So the name becomes, you can write the name like this. That is 2-methyl butane 2-all. Okay, similarly do this. CH3 single bond carbon, CH3, CH, CH3, here we have C2H5, and here we have OH. Good. Try this, send the answer on the chat. Yes. That is correct, Sufyan. बाकी लोग को नहीं आ रहा क्या? हम फीचर यार. No, Mariam, not right. चलिए, देखिए. So functional group is going to be, again we have OH, so it will be all. Then unsaturation, there is no double or triple bond, that is why AN. Then parent. A parent should have this particular carbon atom, right? This carbon atom. So is this going to be a parent? So see, what you should always do is, see, this particular carbon should be parent. So 1, 2, 3. Now I can go above, I can go on the left side, or I can go down. So where do we have more carbon atoms? We have more carbon in the downside. 3, 4, and 5, right? There are 2 carbon atoms here. So 1, 2, 3, 4, 5, that will give you pen. Then subsequent, what are the remaining parts? So this is going to be your parent 1 methyl and 2 methyl. So there are 2 methyl group, that will be dimethyl. Dimethyl in which position? 3, 3. and the OH group is in the second position. So the name will be, let me write it here, 3,3 dimethyl pentane 2 all. इसे कीजिए जरा, CH3 single bond carbon, here CH3, here double bond carbon, Br CH2 OH. All of these questions are from the previous year board examination. The first question was from 2020, the second question was from 2018, now this is 2017 question. Very good. करेक्ट है सुफियान. चलिए, आमना और मरियम. आमना, आप पहले बात ये बताइए, आमना आपके पास 11th स्टैंडर्ड के नोट्स हैं? आमना, डू यू हैव द 11th स्टैंडर्ड नोट्स? आमना, हेलो, एम आई ऑडिबल? आवाज नहीं आ रही है क्या? Since Mariam Lohani and Mariam Batul, both of you have problem in IPAC nomenclature. जी मरियम बताएं.
Not much, but a little bit.
Sorry, what?
A little bit.
Okay, what about Mariam Lohani? I'm not, I mean, sorry, you're not audible, Mariam Lohani. अच्छा, by the way, Mariam Batul and Mariam Lohani, tell me, do you always identify the longest carbon chain? पहले सबसे पहले यही काम करते हैं अगर आप, तो I think that is one of the most common mistake that people do. And books में भी वैसे ही पढ़ाया जाता है, teachers भी वैसे ही पढ़ा, longest carbon chain, longest carbon chain, but that is not the case. First of all, you have to identify if there is any functional group unsaturation, and then only the parent carbon chain should be identified. ठीक है, चलिए, तो यहाँ भी फिर से देखते तो OH we have that functional group, it is all. Unsaturation is, there is a double bond, so it will be En. Then the parent will be the longest carbon chain, including the longest carbon chain, including the alcohol, right? The alcohol carbon should be included. So 1, 2, 3, and the unsaturated part should also be included. The double bond should be also included. So 1, 2, 3, 4. I think इसमें आपकी गलती नहीं हुई होगी. Then you have substituent. Substituent is whatever is remaining. What is remaining? Bromine and CH3. So bromo for bromine, methyl for CH3. ठीक है. अब यहाँ पे अगर हम देखें नंबरिंग करते हैं तो नंबरिंग शुड स्टार्ट फ्रॉम दैट कार्बन एटम व्हिच इज नियरेस्ट टू द functional group. It should start from here. 1, 2, 3, 4. So the functional group all it is in the second carbon atom. Sorry, no. First carbon atom. The double bond it is in the second carbon atom. By the way, double bond it is in the second carbon atom as well as the third carbon atom. And no, double and third. Second and third. Double bond is in second and third. So which one we should take? The lower one. Second. ठीक है. Second में आपके पास double bond है. Then we have bromine is also in the second carbon atom. Methyl is in the third carbon atom. Right. Now, what should we write first, bromo or methyl? I hope you guys know this, that bromo will come first. So that is why 2 bromo. Alphabetical order, है ना? P methyl, but, 2 in, 1 all. If you don't write in 1 all, you can also write in all. है ना? That's also fine because OH when it is in the first carbon, तो वही होगा. चलिए, इसको copy कीजिए. If you have problem, please message me. I will send you a playlist. From there, you can watch the lectures of IUPAC nomenclature और फिर आपको ठीक हो जाएगा, है ना? अब इस चैप्टर में ये है ना कि like I mean, IUPAC nomenclature it requires time, quite a bit of time. चलिए इसका तो हम ही बता देते हैं. इसमें मेनली दिक्कत ये हो जाती है कि बच्चे दे थिंक दैट दिस बेंजीन रिंग विल बी द पेरेंट कार्बन चेन बिकॉज इट हैज 6 carbon. But that's not the case. The parent carbon chain will be that one which has the functional group. The functional group is present here. OH do we do have OH. The functional group will be all. And is there any unsaturation? Yeah, unsaturation is also present. That is En. Then the parent carbon chain is going to be 1, 2, 3 carbon atoms. It will be prop. Now we are going to look at substituents. So whatever is remaining after the identification of puff is substituent. So we have this particular ring which is known as the phenyl ring. So this is phenyl. अब नाम यहाँ पे अगर हम देखें तो this will be 1 all, this will be 2 in, and phenyl will be 3. So 3 phenyl, prop, 2 in, 1 all. Again, instead of in 1 all, you can write in all. No, that's not a problem. Tell me. Raise your hand if you're done. Let us see one for ether also. CH3O carbon atom. Above we have CH3. Below we have CH3. And here also we have CH3. ठीक है. तो अब इसके IUPAC nomenclature के लिए क्या किया जाएगा? तो यहाँ पे please understand that here we don't have any functional group, है ना? According to IUPAC nomenclature, we don't have any functional group. Is there any unsaturation? No, we don't have any unsaturation. अच्छा, when we don't have any functional group, we write E. ठीक है. Now this is a method that I have for some device name and with some other books they also. राइट ई, है ना. जनरली एनसीईआरटी में इस तरह से आपके पास नहीं मिलेगा, बट एंड इट विल वर्क फॉर 99% ऑफ द केसेस. ठीक है, और इससे काफी आसान हो जाता है दैट यू हैव टू लुक एट वन थिंग एट अ टाइम. फर्स्ट ऑफ ऑल फंक्शनल ग्रुप, देन अनसैचुरेशन, देन द पेरेंट, देन द सब्स्ट्रेट, है ना. तो एस पफ हम इसको बोलते हैं, एस पफ. We don't have any unsaturation, so for that I will write AN. What is the parent carbon chain? So parent carbon chain will be what is the most carbon atom we can see in a straight line or joined together is three carbon atoms, right? You can either take this one, that's also fine, or you can take this one, this is also fine, or you can take the straight one, which is this one, that is also fine. Okay, all of these are same thing, which is my so you can take this as three carbon atoms, it will be prop. Then we have substituents, so we have two substituents here. We have a simple methyl group here, that is CH3, and then we have a methoxy group, methyl, which is bonded with oxygen. So this is going to be methoxy group. So यहाँ पे आपके पास you have methyl and you have methoxy. Now, if I number it, you can number it from any one of the sides, 1, 2, 3. It's not going to change anything. The methyl group is also in the second carbon atom. The methoxy is also in the second carbon atom. So the name will be 2, which will come first, methyl or methoxy. So YL, meth and O. So methoxy will come first, 2 methoxy, 2 methyl propane. Copy this down, raise your hand once you're done. Please message me on WhatsApp if you need lectures of IUPAC nomenclature. It will be very beneficial for you if you have any difficulty. Also, बिल्कुल हमने individual like functional group, we have one video. For unsaturation there is one video, for parent there is one video, for subsequent there is one video. A bit of theory and a lot of questions is present, so you don't have to watch the lecture, you have to do the lecture, in the sense that you have to sit with pen and paper and do the problems, while the lecture is going on. If you are not going to do that, if you're just going to listen, you'll get some idea, but you will get stuck in some typical type of question, which are a bit tricky type of questions. Amna, I'm waiting for you. I don't know whether you are present or not present. अब disconnect हो गए थे. Amna, are you there?
Yes, sir.
Okay, thank you. Raise your hand once you're done. Chalo. Right, next, common name of ethers. Common name of ethers. CH3, OCH3. Okay. So here we have two methyl groups on the ether, so it is known as dimethyl ether. ठीक है, उसी तरह बताइए इसका क्या नाम हो जाएगा? C2H5O C2H5, बोलिए जरा जल्दी से बोलिएगा प्लीज, ज्यादा टाइम मत लीजिए. व्हाट इज दिस ग्रुप?
Diethyl ether.
वेरी गुड, डाइथाइल ईथर. जो बोल देगा भाई उसी को आएगा ज्यादा, है ना. तो ट्राई टू स्पीक डाइथाइल ईथर. ठीक है. लेट्स सपोज वी हैव C2H5O and CH3. तो इस केस में here we have ethyl group, here we have methyl group. So in alphabetical order, ethyl will be first. So ethyl, methyl, ether. ठीक है, उसी तरह से you can have some complex cases also, but इतना जरूरत नहीं है, बस फिर. So this is isopropyl group. It will be isopropyl. This is isopropyl. This is methyl. Isopropyl, methyl ether. ठीक है. और अब एक तो और नाम है, फॉर एग्जाम्पल दिस इज anisole. Now this is so common that IUPAC just accepted this as a particular name. This is anisole benzene with OCH3. अब यहाँ पे फॉर एग्जाम्पल इफ यू हैव बेंजीन रिंग वाला ईथर एक और ले लेते हैं, फॉर एग्जाम्पल इफ यू हैव समथिंग लाइक दिस OC2H5. So this will be ethoxybenzene. Ethoxy ethoxybenzene. This is IUPAC name. The common name will be ethyl phenyl ether. Right? This is ethyl. The other thing is phenyl. It will be ethyl phenyl ether. Ethyl phenyl. I hope this makes sense. In sorry, like just revise these names. No need to memorize these things, but memorize anisole at least. Okay. अच्छा इसमें एक और आपके पास हम नाम बोल देते हैं. This one thing that is जनरली आ जाता है ऑक्सीजन विथ टर्शरी ब्यूटाइल ग्रुप. ठीक है. So here we have one carbon, two, three, four carbon atom. One both of these groups are tertiary butyl. So this is known as di-third butyl ether. Common name क्या है इसका? Di-third butyl ether. Raise your hand once you're done. Waiting for Mariam Batul. Next is the classification of alcohols. Classification. So please see first, don't write. Alcohols can be classified into some categories. I hope you know that we have 1 degree alcohol. 1 degree alcohol will be having the RCH2OH. That means the carbon which contains alcohol will be 1 degree. है ना? जिस कार्बन के पास अल्कोहल है वही 1 डिग्री होगा, एंड दैट वेन वी कॉल इट 1 डिग्री अल्कोहल. इसी तरह देखिए यहाँ मोर Then we have 2 degree. 2 degree, in this, the carbon which is containing alcohol will be attached to two different carbon atoms. यहाँ पे एक और क्या जाएगा, हाइड्रोजन आ जाएगा. Then we have 3 degree. In this, the carbon will be attached to three carbon atoms, which is further attached to OH. Okay. So the degree of alcohol is the degree of carbon to which it is attached. Basically, यही है. Next, we have some other cases. For example, allylic. Now, in allylic, what happens? There is a double bond, then there is a sp3 carbon, and then there is a OH group. So basically, यहाँ पे double bond, then we have sp3 carbon और इस पे OH. This thing can occur on a cyclic case also. For example, यहाँ पे double bond, sp3 carbon, and then here we have OH. है ना? कुछ भी हो सकता है इस तरह से. All of these are cases of allylic alcohol. Then we have vinylic. In this, the double bond carbon atom is directly connected with OH. उसके बाद something like this. Then you have the last case, which is benzylic. So by the way, allylic can also be called as allyl alcohol, vinyl alcohol, benzyl alcohol. Okay, benzylic alcohol. Here you have benzene ring, which is connected to an sp3 carbon, which is then connected to OH. Benzene ring, carbon atom, and then OH. ये तो 1 degree, 2 degree, 3 degree, allylic, vinylic, benzylic, all of these we have also studied in the haloalkane chapter, है ना? ठीक है. If you have written this down, तो बस एक पॉइंट लिख लीजिएगा. When OH is directly connected to benzene ring, then it is called phenol. Which is a different functional group. ठीक है, it's not same as alcohol. There is no concept of aryl alcohol. Aryl alcohol जैसा कुछ नहीं होता है. बेंजीन जब कनेक्टेड होगा तो से OH से, then it is going to be phenol. That's it. खत्म बात, है ना? Raise your hand if you're done writing this. Waiting for Mariam Lohani. Next is classification on the basis of number of OH attached. Classification on the basis of number of OH attached. These things are very basic, but still आपको ये सारी चीजें ऐसे एक बार नजर से गुजर जाए तो अच्छा है ना. तो फर्स्ट वन इज मोनोहाइड्रिक. This contains only one OH group. Second is dihydric, contains two OH group. Trihydric, just give me a second. इसको कंप्लीट कर लीजिएगा ट्राइहाइड्रिक के लिए. Okay, so trihydric will contain three OH group. Then we have fourth one, that is polyhydric. That contains more than one OH group. ठीक है. You can write some examples also. I mean, very easy examples. This is ethanol. ठीक है. अच्छा, इथेनॉल को ना ऐसे भी लिखा जा सकता है ETOH. ठीक है, तो इथाइल अल्कोहल टाइप से बोला जा सकता है. This is sorry monohydric. Then we have ethylene glycol, which is CH2, which is bonded with OH. Here also we have CH2, which is bonded to OH. And you can simply write it like this: OH in this carbon atom, OH in this carbon atom, CH2OH and CH2OH. So the name of this molecule is ethylene glycol or just glycol. Ethylene glycol or just glycol. You can have even more. For example, you have OH, OH, and OH. Here you have one carbon atom, two carbon atom, and three carbon atom. All of these three carbon atoms, they're having one OH group. And this molecule is known as glycerol. Okay. Now, here we have, next we have some phenols. Sir, is it not more than four? नहीं. Poly में आपके पास more than one नहीं, poly हो जाएगा. Poly means more than one. जैसे polygon क्या होता है? Multiple sides, right? Polynomial है ना? तो poly में more than one. So even dihydric and trihydric are example of polyhydric alcohol. Next we have phenols which have two OH groups. So if the OH group they are in the ortho position, first of all, OH and OH, this is ortho position, this is known as catechol. All of these structures are there in the NCERT. इस वजह से आपको ये एटलीस्ट एक बार गुजर जाए. पता नहीं कौन सा, मतलब if they ask a question by the name catechol undergoes a reaction and so on. तो फिर आपके डिफिकल्ट हो जाएगा. Then if it is in the meta position, this is known as resolve theorem. वैसे एनसीईआरटी में कोई सवाल है नहीं, but these structures are present. And if you have the benzene ring and OH present in the para positions, so one of the name is phenol, this is quite easy, quinol, or this is hydroquinone, hydroquinone. ठीक है, hopefully you are writing this with me. Just एक बार आप बहुत बार alcohol बना लीजिए. Then we have another example, some common names that you need to know. Phenol with one CH3 group. ठीक है, so this is known as cresol. Now there are three different cases in which it can happen. When the CH3 is in the ortho, in the meta, and the para. So when the CH3 it is in the ortho position, OH and CH3, this will be known as O-cresol, that is orthocresol. Now I hope now you can understand what is coming next. OH, CH3 is M-cresol, OH, CH3 is P-cresol. For Amna, Mariam Batul, and Mariam Mohani. Just waiting for Amna. Now, write a remark. This is very important point that you have to understand. एक बार point को लिख लीजिए मेरे साथ साथ, and I will explain it. Please write this with me. More than one OH group. One OH group cannot be present on same carbon atom. Same carbon atom as the molecule becomes very unstable and water is released. ठीक है, एंड वाटर इज रिलीज, है ना, हम बता रहे क्या होता है यहाँ पे, और आप समझिएगा इसको। आई मीन दिस इज अ पॉइंट विच इज इंपॉर्टेंट, एक रिएक्शन में काम आने वाला है। ठीक है, वहां पे आपको बस ये ना लगे कि ये क्या हो गया। ध्यान से देखिए, फॉर एग्जाम्पल आई हैव अ कार्बन एटम विच हैज टू OH ग्रुप। ठीक है, इस तरह का केस हमारे पास, we have a carbon atom which is having two OH groups and it is attached with one alkyl group यहाँ पे। Now what is going to happen? See, this hydrogen atom, because it is attached with oxygen atom, it will be having a delta positive charge. Because oxygen is electronegative, it will be pulling electron from itself. Now here, this particular oxygen atom, it is having a lone pair. As soon as this particular molecule is formed, ये तुरंत ही यहाँ पे ऐसे अटैक कर देगा, because electron is already present, so electron will be attracted towards the positive charge. And what is going to happen? This H2O molecule, I hope you can see that it is going to leave. This is going to break. So minus H2O, और यहाँ पे आपके पास आएगा R, C double bond O, and H will be removed. And I hope you can see that. जैसे as soon as this particular attacks on this hydrogen atom, this hydrogen will break the bond and it will give the electron density to the CO bond. यहाँ पे C double bond O will be remaining and H is going to be here. ठीक है, so it is going to form aldehyde. If in any reaction we get carbon with two OH, then it is going to form what? It is going to form aldehyde. Now, similar case, but there is only one change. That instead of this hydrogen atom, there will be another alkyl group, R dash, let us suppose. Then instead of this hydrogen, here also there will be an R dash group, and this will be known as ketone. Next, if you have three OH groups, then what's going to happen? R, C, here we have OH, here also we have OH, and here also we have OH. Here also the same thing is going to happen. This water molecule is going to leave. This particular bond is going to move here. And we will get R, C double bond O. And OH, which is carboxylic acid. Raise your hand if you're done. ये समझ में आया ना सबको? What is happening here? Mariam, Sufyan, and Amna.
Yes, sir.
Yeah. Okay. So now we are going to start with the method of preparation of alcohols. The program. Now you can write the heading. MOP of alcohols. Okay. Number one, from alkenes. From alkenes. है ना? In alkenes, we have to see there are two main that we have to see. That is acid catalyzed hydration and hydroboration oxidation. Okay. So number one, A लिखेगा in from alkenes. The A part is by acid catalyzed hydration. Okay. Now what is basically happening here is carbon with double bond carbon. No matter what groups are attached here, it doesn't matter. I am going to add water in it. That is why it is hydration. And this will be in the presence of H positive in the presence of acid. So what's going to happen? One of the double bonded carbon atom will get hydrogen and the other will get oxygen atom like this. Okay. So यहाँ पे आपके पास क्या होगा? Whatever two bonds are attached, that will be attached as it is. One of the carbon will get hydrogen. The pi bond will break to single bond, and then here you will be having the two groups as it is, and here you will be having the OH. ठीक है? तो यहाँ पे सबसे पहली चीज ना very basic thing that you need to always have is first of all what is breaking and what is getting formed. That is the most basic information that you need to have for every reaction that you remember. तो जब भी कोई reaction आप देखें, then always try to see that okay what bonds are breaking, what bond is getting formed. So what bond is breaking here is C double bond C में pi bond is getting broken and this one is getting formed CH. एक आपके पास CH sigma बन रहा है और I can write only CH bond and then COH. Both of these sigma bonds are being formed. Both of these sigma bonds are being formed. ठीक है? Now, make sense this one please tell me guys.
Yes, sir.
ठीक है. Now, you can write the statement. When alkenes are treated with आप लोग क्लास कब तक है यार हम भूल जा रहे हैं आजकल नया टाइमिंग स्टिल ठीक है वी हैव 15 मिनट्स ना ठीक है when alkenes are treated with water in the presence of protic acid protic acid you can also write only acid there's no problem and generally we use H2SO4 they undergo addition reaction and form alcohol according to Markovnikov's rule. All of you guys remember what is Markovnikov's rule? हाँ भाई याद है कि नहीं याद है मरियम मरियम बतूल आमना सुफियान
Yes,
The
sir.
negative part of the addendum gets attached to the
हाँ
lower
जी
carbon.
लोअर पर
नहीं मतलब
कार्बन विथ
जिसमें
मोर
कम कार्बन होता है वहां पर
जहाँ पे कम कार्बन होता है
कम हाइड्रोजन होता है सॉरी
कम हाइड्रोजन होता है जी हाँ ठीक है तो इन दिस वाटर व्हाट इज द नेगेटिव पार्ट OH इज द नेगेटिव पार्ट है ना अगर हम वाटर को देखें तो वाटर कैन बी रिटन लाइक दिस HOH So this is delta negative, this is delta positive. Right? So this is the negative part which is going to get added on the carbon with less number of hydrogen, right? We can write OH attaches to that carbon which has less number of hydrogen. ठीक है, चलिए उसके बाद we are going to do some questions. Done everyone? दिख रहे हैं क्या अभी भी? Please raise your hand if you're done, guys. ठीक, चलिए. Hopefully आप लोग को इसमें दिक्कत नहीं होनी चाहिए, है ना? अगर फिर भी दिक्कत हो रही होगी तो बताइएगा प्लीज, है ना? I'm going to do some questions and then I will give you some questions. If I have CH2 double bond CH2 and in the presence of water and H plus, then we are going to have an addition reaction. In this case, what is going to happen? We are going to have CH3, CH2 and OH, है ना? तो OH लग गया. Like both, this is symmetrical alkene. In symmetrical case, we don't have to do anything. किसी में भी OH डालिए, किसी में भी H डालिए. Not going to matter. Second is when we have CH3 singly bonded with CH and then we have doubly bonded with CH2. In this is not a symmetrical alkene. The same reagent is present, H2 and water. Sorry, H2 in the presence of H positive. Now, this carbon, it has one hydrogen, this has two hydrogen. So OH will attach on the carbon atom which is having less number of hydrogens, so it is going to be something like this. The pi bond will be always broken. So don't forget to break the pi bond. Third is when you have something like this, let's suppose in this case everything as it is without the pi bond and OH on the carbon which is having less hydrogen. In this case, both the carbon are having same number of hydrogen. That is why you can attach the OH here or this carbon is going to be same, nothing is going to be different. The fourth case, let's suppose we have something cyclic. We have double bond here and we have CH3 here. In this we have two carbon, this carbon and this carbon, they are having different number of hydrogen. Here we have 0 hydrogen, here we have 1 hydrogen. Right, so in this case, everything as it is first of all, and the carbon with less number of hydrogen will get the OH. Okay. I hope these 4 questions are enough. I hope now you can do some other questions on your own. Sorry, do it please. Mariam Batul, do I need to scroll up even more?
Just for a second, sir. I just want to see one thing.
Ah, yes, sir. Okay. Even more?
No, no. Okay, fine. You can slow down. Thank you.
No problem. Send your answers on my WhatsApp once you're done. Let me know if you have doubt in any one of the questions. Yes. Sufyan, very good. That is correct. Mariam Lohani and Mariam Batul and Amna. Guys, what happened? Send me whatever you have done so that I can check it also. Yes, Amna and Mariam, what happened? Oh my God. Mariam, नहीं किया आपने अच्छे से। चलिए ठीक है, अभी तो अब इसको हम नहीं करेंगे। वी आर गोइंग टू एक्सप्लेन दिस। मरियम बतूर, कैन यू प्लीज टर्न योर माइक ऑन? मरियम, अब एक बात सही से बताइएगा, आपको जहां पे लग रहा था आपने वहां पे वॉच डाल दिया क्या? डिड यू काउंट द नंबर ऑफ हाइड्रोजन ऑन द डबल बॉन्डेड कार्बन एटम की कहाँ पे डलना चाहिए, कहाँ नहीं डलना चाहिए? काउंट किया आपने या फिर ऐसे ही जहां पे आपको लग रहा था कि यहाँ पे कम होगा शायद यहाँ पे डाल देते हैं, ऐसे किया आपने?
Oh, I didn't
काउंट?
count. Really.
नहीं, ठीक है, चलिए ठीक है, तो फाइन। आई अंडरस्टैंड। काउंट करके एक बार फिर से कीजिएगा, ठीक है ना? हाउ आर यू गोइंग टू काउंट, हम आपको बता देते हैं किस तरह से काउंट करना है आपको।
Okay.
फर्स्ट ऑफ ऑल देखिए ध्यान से, मेक एवरीथिंग एज इट इज, फर्स्ट ऑफ ऑल, है ना? इसमें आपके पास यू हैव टू मेक एवरीथिंग एज इट इज अदर देन द डबल बॉन्ड। डबल बॉन्ड के अलावा सब कुछ कर लिया आपने। द OH कैन बी ऑन दिस कार्बन एटम, दैट मींस या तो यहाँ होगा या तो दिस कार्बन एटम, दैट मींस और हियर, है ना? ईच एंड एवरी स्टेप यू हैव टू फॉलो इट लाइक दिस ओनली, देन ओनली इट इज गोइंग टू बी करेक्ट। और बार बार अगर आप मिस्टेक करते रहिएगा, इफ यू आर गोइंग टू स्किप स्टेप्स, तो फिर मिस्टेक होगा और फिर वही आप एग्जाम में करके आइएगा, ठीक है ना? तो क्या करना, सबसे पहले ड्रॉ एवरीथिंग एज इट इज विदाउट द डबल बॉन्ड, राइट? So draw everything as it is without the double bond, then identify where the OH can be. So on this carbon or on this carbon atom. Now, for both the carbon atoms, we have to count the number of hydrogens. So in this case, we have 3 bonds, so there will be 1 hydrogen. In this case, we have already 4 bonds, so there will be 0 hydrogen. There will be 0 hydrogen atom. So which carbon it should go? A carbon और B carbon किस पे जाना चाहिए बताइए? OH को कहाँ लगना चाहिए? Which one?
A.
ठीक है, अब एक बार इसको पढ़िए दोबारा। Read the statement. OH attaches to that carbon atom. पढ़िए पूरा।
Which attaches to that carbon which has less number of hydrogens.
ठीक है, very good. Now can you please tell me in which carbon it should attach, A or B? Yes, Mariam.
So A has less hydrogen, right?
ठीक है, A has how many hydrogens? How many
Three.
hydrogens in? आप आराम से बोलिए, जैसे डर के बोलिएगा तो आवाज ही नहीं आएगी, है ना? State properly. How many hydrogens
Three.
in the A carbon? Sorry, I did not get it. Can you please repeat that?
Three.
3 hydrogens in the, यार यहाँ लिखा है हमने 1 हाइड्रोजन, मरियम बतूल।
Okay, one hydrogen is there and
नहीं
three
नहीं 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 नहीं, सुनिए सुनिए सुनिए, आपको मतलब यू डोंट अंडरस्टैंड। कैन यू राइट द स्ट्रक्चर? अब इसको CH3, उसके बाद क्या आएगा? दिस इज CH3, राइट? आफ्टर दैट व्हाट वुड बी देयर? यहाँ पे क्या आएगा?
CH.
CH, एंड देन?
And then again CH.
नहीं, डबल बॉन्ड सिंगल बॉन्ड कुछ तो होगा।
हाँ, double bond.
डबल बॉन्ड एंड देन
CH.
CH, ओके, एंड देन
And then CH3.
CH3, Is there anything left? Oh, yeah, हो गया.
There's a methyl.
Where is the methyl? In which carbon atom?
The carbon after double bond.
ठीक है. CH3. Is there anything left? या हो गया?
तो एक हाइड्रोजन निकालें तो
I
फोर्थ
don't
कार्बन,
understand.
थर्ड कार्बन,
थर्ड कार्बन से क्या करना पड़ेगा?
एक हाइड्रोजन हट जाएगा because it's already filled with the other ones.
ठीक है. चलिए, वेरी गुड. नाउ यू टेल मी हाउ मेनी. अब किस कार्बन पे लगेगा? विच कार्बन शुड गेट दी OH? A कार्बन और द B कार्बन?